The integral of square root of x squared minus 1 over x cubed times dx is, first we're going to do some u substitution. So let u is equals to x square root of x squared minus 1, then differentiate it. So 1 half times x squared minus 1 raised to negative 1 half 2x dx. So our simplified du is x over square root of x squared minus 1 dx. Then substitute all the x with u to the value of u. So we get the value of x, which is square root of u squared plus 1, then plot it in the original here. Then now we get in respect to u, so integral of u over square root of u squared plus 1 raised to 3 times u over square root of u squared plus 1 times du. Then simplify, we get u squared over square root of u squared plus 1 raised to 4. Then since it's square root, we can cancel the 2. Then we get the simplified form u squared is equal over u squared plus 1 raised to 2 du. With this, since we reached this step, we're going to use the trigo substitution. Since here, we get the format of x squared plus a squared, we can use the x is equals to a tan theta. So, u is equals to a tan theta, where u is equals to 1 and a is equals to 1, then u equals to tan theta, then differentiate, du is equals to sec squared theta d theta. Then plug it in again in the original. So then we get the tan squared theta over tan squared theta plus 1 raised to 2 times sec squared theta d theta. Then simplify, since tan squared theta plus 1 is equals to sec squared theta, then cancel sec squared theta, then we get tan squared theta over sec squared theta. Then since tan squared theta is equals to sine squared theta over cos squared theta, and secant squared theta is equals to 1 over cos squared theta, then reciprocal it. The reciprocal of it is cos squared 2 theta d theta. Then we can cancel the cos squared theta and cos squared theta. Now we only left with sine squared theta d theta. Since sine squared theta is equals to 1 minus cos squared theta here, then distribute the integral sign, which is integral of d theta minus integral of cos squared 2 theta d theta. And cos squared 2 theta is also equals to the double angle here, which we can get the 1 minus cos 2 theta over 2 d theta. Then simplify, theta minus 1 half integral of d theta plus 1 half integral of cos 2 theta d theta, where our u is 2 theta, then du is equals to 2 d theta. Then the integral of those is theta minus 1 half theta plus 1 half times 1 half cos 2 theta plus c. And then, since sine 2 theta is also equals to 2 sine theta cos theta, then we can substitute it, then we have 1/2 theta plus 1/4 times 2 sine theta cos theta plus c. Then simplify. Then we get 1/2 theta plus 1/2 sine theta cos theta plus c. Then return it to the original values. We will use the right triangle to form the values. So since we use the u is equals to a tan theta, then tan theta is also equals to u over a. Then we can substitute it in the triangle, and we get the value of the final answer. So for theta, we have arctan u over a. Then for sine theta, we have u over u squared minus 1. Then cos theta is 1 over u squared minus 1. Then we get 1/2 arctan u plus 1/2 u over u squared plus 1 plus c. Then substitute the value of u, which is, we have the final answer 1/2 arctan square root of x squared plus 1 plus 1/2 times square root of 2 minus 1 over x squared plus c.